All right, everyone, here we go. Let's tackle this here real quick. So, this is tackling independence. So, the idea is that it doesn't matter that you toss it 4 times because each coin or each time you flip a coin, it doesn't affect the next one. So, this is just to kind of throw you guys to think about all this other stuff. And then they ask you if the coin is then tossed 1996 more times, we want theoretical. So basically, what you're saying is we know that theoretically half of them are going to be heads or tails. The idea of long run. Just remember, coin tosses are independent of each other. This is the correct answer because if you add all of them up, it'll equal 1.0. Remember, we got to equal 1.0. Excuse me. Uh, and then from there, we're using this two-way table. It asks for what's the probability that the person plays the woodwind, and there's 14 of them. There's 14 out of 88, so that ends up giving you about that much right there. Okay. Excuse me, guys. The next one, it asks the probability the person is a male. So all of a sudden now we're only dealing with 44 males, and they want to know the probability that it's a woodwind. So we have 8 and 44, which gives us our answer right there. So remember the idea of mutually exclusive means they can't happen together, and we know that playing a woodwind and a male can happen together. So we know they're not mutually exclusive, so it's going to be A or B. But we also know that the probability changes all the time depending on if they play a woodwind or if they're male. So we know that they're not independent. So that's our idea there. For 5, this one's a little bit different. So the way you look at it is if the number 6 comes up 3 times, that means there's 3 times often as any other number. The way you can kind of look at it is it's a 1, a 2, a 3, a 4, a 5, a 6, or a 6. That's 3 times more than everything else. So what's the probability of getting a 6 that way? 1, 2, 3, 4, 5, 6, 7, 8. It's 3 out of 8. And then what's the probability of getting a 1? It's 1 out of 8, which gives you 1/2 or 4/8 is your total. So that's 1 out of 8. Okay. This one here is you're choosing red. Now remember, there's only 20 reds out of a total of 50. And so it's kind of like a tree diagram. And so we've got 20 of 50 here. But then when I get to here, I have 19 of 50 because there's 19 left, right? There's 19 left and there's 30 left of the black marbles. So it's going to be 19 of 50. So we're going to do 20 over 50 times 19 over 49. And that's going to give me my answer. Here's our probability conditional formula. Remember, on these, you want to be able to use the formula sheet for these pieces. Probability of A and B over the probability of B is 0.1 divided by 0.6, or 1/6 right there. And that's from your formulas, guys. All right, so we may conclude that either A or B always occurs. That's because the idea that the probability of A plus the probability of B minus the probability of A and B, that's going to equal 1, is the idea behind that. Excuse me. don't know what's going on. And so if you look at that, that's 0.5 plus 0.6 minus 0.1. That's going to equal 1. Because if you just add those two together, you get 1.1. But we know that A or B is always going to occur because these are greater than 1, but when we subtract out the probability of them occurring together, it takes out the counted twice option. Yes. All right. So the trick to these right here, the probability of at least 1, that is your complement here. Okay. That's your complement. So we know that the probability, and sorry for the highlighted pen, that fire alarm kind of messed everything up. So the probability of at least 1 is the probability that it's going to be greater than, you're going to have more than 1, which is the complement of that. So it's going to be the complement of this, and the complement, if 1 is equal to 0.11, we know that the complement is going to be 0.89, but we want it 5 times in a row, 5 months in a row. My alarm's going off, guys. So when you see these at least 1 prize, those are going to be your complement problems. And the easiest way to do it is 1 minus, so the complement of this, the probability of the complement is 1 minus 0.11, which is equal to 0.89. But that's got to happen 5 times in a row. So we just put it to the 5th power. The word independent is the key piece here. The word independent is the key piece. We know that all seniors are 20%. So if it's independent, knowing that they're male or female doesn't affect the percentage whatsoever. So what's 20% of 40? 2 times 4 is 8. That's kind of how I tackle that one. These are on the key. Let me grab the key over here, guys. It's a little bit better. So what's the probability the Roadrunner gets caught? Remember, he gets caught if he takes the low road and gets caught. That's this one here. And then the high road and gets caught. That's this one here. And so when we multiply those together, we get the probability that he gets caught. Okay? So this is the high road and gets caught. This is the low road and gets caught. Get used to that terminology right there, guys. Probability. So this is that one from the formula sheet. The probability that he gets caught and he takes the high road. So we need the probability that he gets caught on the bottom, which is my answer from up here. So we had and then the probability that they both can happen, which is 0.8 times 0.01, and that gives me 0.44. Again, this is from your formula sheet. Okay? So the idea is this. When it comes to independence, the formula that he gets caught, the probability that he gets caught and the probability that he took the high road and gets caught are different. That means they're not independent. That means knowing that he took the high road affects the probability that he's going to get caught. Now, if this high road and caught was 0.026, then these would be independent because that means the high road does not affect his ability of getting caught. That's the key idea behind it. Okay. On 13 here, it's easier to do either a two-way table or a Venn diagram. I don't care, each one. Don't worry about this chicken scratch off to the side. So for A, it's the probability that he's going to, of both of them happening, probability of A plus the probability of C, so apple or chips, minus the probability of apple and chips. So we're going to do 0.21 plus 0.36 minus 0.09. Okay, minus 0.09. All right, so this one here, we have, and then if you want to, this is 0.21, this is 0.36, and this is 0.09 comes from there. Randomly selected fruit and a snack, it's 0.21 divided by 0.48. Sorry, guys. And then that's going to equal the 0.4375. Okay. And again, these are from the formula sheet. So make sure you know that these are all from the formula sheets right here. All right, let's do the last one real quick. This one here, I'll do it on the back here. So number 15, make sure that you're going to do state. Oops, where's 15 at? There it is down there. Make sure you're going to do a state, a plan, a do, and a conclude, okay? So make sure you state what you're looking for. So we will estimate the probability of taking less than 10 calls, and then we're going to do 5 trial simulations. Make sure you state those pieces. Your plan, don't forget, you can either do the numbers from the table, and when you do that, don't use 100. Don't use one. This is, if you go to 100, you got to go from 001 to 030 because you got to keep the digits the same. Okay. So this is why I don't like using the table, because then you have to use 3 digits when you do that. That's why it's easier to do pairs on the digit when you're out of 100. You go 0 to 29. That still gives you 30 choices. And then 30 to 99 is 70 choices. It's easier to do your random int in the calculator, where you're going to go from 1 to 30 and then 31 to 100. You can even do names in a hat. So 1 to 30 calls in a reservation. If you use the table, it's going to be 00 to 29. Then you're going to have to do all the trials, and you're going to have to show all the trials and list them out, and then make your conclusion of that it was 2 out of 5 trials, so therefore the probability of getting 3 reservations and less than 10 calls is 40%. That's the idea. The biggest thing here is state your plan, your do, and conclude. Remember, you're going to get 2 points apiece for these. Okay? You're going to get 2 points apiece for those. And the last thing here is, don't forget, when they ask you to interpret it, just remember, over many, many calls, over many, many rolls of the dice, whatever it is, the probability that the call reservation in a reservation results in a reservation is approximately 0.30. That's literally interpreting everything you need to know there. So good luck, and we'll talk to you guys later.